Sometimes the job becomes a responsibility, and you can have good taking of tidings then about doing the job now. Now, Mr. Tesla over here, of course, spent a lot of time researching resonance circuits and everything, and I'm quite inspired by him. But a funny thing happened one day when I moved Mr. Tesla from his place where he was looking over my living room. And the bad thing that happened, oh my goodness of all, was that my brother Robert Norris died very same night. And Bobby always helped me with my work. I think that plaque over there represents his, well, it is his work from when he was a young child. He was of two brothers, deceased this July, and I wanted to make this thing and note it because Bobby always helped me in work. I want to donate this video of the Ferrite heating effect, or I want to let Bobby know that he's still well at work, because we're going to use your plaque there sort of help us in this demonstration. So God bless you, Mr. Brother of mine, Robert W. Norris, and let us tell you, you're still going on in the world with this work. You're inspiring me. Now then, we got to go to the situation at hand. This is the 6th embodiment. Thank goodness I didn't start the clock. Well, we'll work with it. Because we're stepping ahead a little bit, we can't quite go into in this video what the 4th and 5th embodiments were, but to briefly describe, what we had before was the 266 wafering system with two secondaries on the outside of the system. In this embodiment, we put them inside the coil system. I think I'm recording, I hope. Well, there they are, you know. So I'll go to check to see if I assume we're recording. Well, there you go, you see. Now we got them two high induction coils between the pancake wafers, and we can do experiments about that. But for now, we just want to show this legendary Ferrite heating effect there. Yeah, I think it's quite spectacular myself. But to describe it, I got to put that schematic back up there, and that'll be okay. I would hope that's okay. Okay then. Well, you see on the right hand side there, we got two rectification systems on two of the three interphasal resonances. Now what we've done from the last video is we have added capacities. The old man's eyesight ain't what he used to be. Well, I had to have added capacities to each of the pancake coils, but on the schematic we're trying to show here that we've got rectifications on the outside system, and we also have rectifications on the inside system. Dual rectifications from three-phase, which is the same thing as taking three of them on a delta output. Now then, we're going to turn the, what we have done here is we've conditioned the ferrite. And to get to the end of this damn film, what we're going to do is show the ferrite, and we're going to turn the machine on with no field, and then we're going to, it looks like we've got a fuse. Well, when they condition the ferrite, it'll put a fuse mark on it, and it will change it to a state of instant conductivity when the voltage outputs are applied. We're going to have to get to a better camera viewpoint of that piece. That should probably be better. Now, first of all, we're going to then turn the process on, make sure all the relevant meters are working. You will see here then that our measuring, where is the camera? Good lordage. Our measuring instruments on the output are the two yellow ones. And this yellow one is our DC voltage, because we're measuring everything on DC, on our output. On our inputs, we're going to be measuring AC. All of our AC inputs are going to be governed over there. So now we're going to go in there and let my brother know he's still working here. We're going to use his plaque to prop things up so we can continue this thing with a muffled sound, I think. But we want to see our inputs first of all on turn on, so we can rapidly go to the next stage where we actually engage the field. Okay, now then, it's not a very good camera viewpoint, but as I've rehearsed before, today I put three new batteries on our middle and left and right voltage meters, stator voltage meters. The phenomenon of achieving different voltages on each different phase is somewhat of a puzzlement. But we can investigate this a little further, and that puzzlement changes quite a bit when we look at the conditions of our primaries. But for now, as I say, we need to go in there and go back. This is the ambient conditions before we are going to turn the field on, and as I see to the right-hand meter needs corrected. For record then we have 0.7 volts, 0.4 volts, 0.5 volts on phases 1, 2, 3, and it looks like for some apparent reason we have very little stator line current in the middle. Well, that's puzzling. I hope there's not a problem with the connection. We'll continue. We just did a condition of Ferrite. Now we're going to show the instantaneous application and note the inputs. Presently we have a 9-volt DC voltage through rectification being procured through the 0.7, 0.4, and 0.5 volts of the stator. And we'll go back and show the incandescent Ferrite effect, if we may, without more other further difficulty. Well, I think right there we are. That should work pretty good, I would imagine. Okay, like we say, this has been conditioned, so when I turn the field on, it should instantaneously go to incandescents that are around in there. That's at a pretty high value, but relative to our inputs, let that go for a little bit. It creates quite a bit of heat. I could put a Fahrenheit laser thermometer on there. I would try that quickly. Really need assistance to do that. I've formerly recorded 800 degrees in this kind of thing. Okay, now we're going to go be looking at our inputs. Not much hurry. Okay, again now, we are operating at a pretty high stator voltage. 22, 22, 22 volts. That all seems to have evened out quite a bit. But look where we are, 2.7, no middle line stator amperage, and 2.25 stator line amperage on the right in the background meters. So, for now we can conclude that we got 2.5 amps on the damn stator lines, and quite a bit of a high stator voltage, but it has equalized out in the application to 22 volts, and that I guess should give us a good idea of our, oh, that was our input now, Ray, hey? Now we gotta look at our output. Let me get in there and turn that other meter on. Output is 15 volts, enabling 3.3, well, you know, there you got 3 amps and 3 some amps and some 15 volts, and there's your output. And I would say that is the end of the ferrite heating demonstration. We're going to have to make another film when we engage the secondary and look at its effects. Right now the secondary is entirely open, and all the amperage is going through that coils. And here is our input. That's what we got. Now again, let's carefully analyze these things. Input now, Ray. This could be very important. We see that we got 2.6, 2.3, 2.9 amps on those 3 layers. That's our input. And our stator lines are inputting that on the basis of a 180 phase load or near it, since we have no current on the center line. This could be due to a mistake. We will investigate it, but for now we've shown the inputs, and once again we can end and show the output, which is 3.6 amps. It now would appear to be 13.6 volts. And ta-da! That must be the end. Well, you know, relative to the beginning. Let me back out and look at things. Yeah, there it is. That is the end. Let's put that camera down. Stabilize it and make it official. You know, like the end of World War II, gotta make it official. We're gonna negotiate this alliance here, and that is the